All right, for Unit 7, we are going to talk about exponential growth, exponential decay, and logarithmic functions. To start off Unit 7, I wanted to start with a word problem on Moore's Law. So Moore's Law states that the processor speeds, or overall processing power for computers, will double about every 18 months. Likewise, the cost to produce a comparable computer will be cut in half. So what does this mean? To simplify the mathematics, we are going to make the assumption that it takes 2 years to double half instead of the 18 months. Okay. I know that's a discrepancy from the word problem, but it's meant to make our life easier for the purpose of learning about exponential functions. So in 1988, the number of transistors in the Intel 386SX microprocessor was 275,000. What was the approximate transistor count of the Pentium 2 Intel microprocessor in 98? Well, we know they're doubling, so double would give us 550,000. Then we'd get 1,100,000, 2,200,000, 4,400,000, and 8,800,000. Okay, the actual number I believe was 7,500,000. But let's take a look at this. Let's try to estimate our graph. So 1998, we're at about 275,000. What is this, a million? So we're somewhere down here. In 1990, we're at 550,000. 92, we're a little over a million. 94, we're a little over 2 million. 96, now look what's going on to our graph, okay? See how much it is jumping each 2 years, okay? So linear, we knew, would go up at a consistent amount, but what we're seeing with exponential is that it isn't linear, it's bendy or curvy. And more importantly, it gets bigger and bigger each double life. Okay. This is called exponential growth. In a time where we're worrying about a pandemic, we don't want exponential growth in COVID numbers. Okay. If the COVID numbers doubled every day, for example, and I'm not saying the data supports it, I'm just using it as an example, that would be very bad. Okay, to double the amount of patients we had every single day would be a very, very bad thing. I bring it up because I want to drive home the point that exponential growth may start off growing slower than linear, but over time will explode at a much quicker rate.